Welcome to the training series on ODOT's Benefit Cost Analysis tool for active transportation improvements. This is Module 3 of our 4-part series. This module will introduce the Cost Opinion Spreadsheet tool, which is a supplement to the overall BCA tool. This module will walk through the Cost Opinion tool at a high level. We'll cover when to use the tool, how we developed it, some key disclaimers and assumptions to consider when you use it, how to make refinements for your specific project, and lastly, an example use case where we'll show you how to use the Cost Opinion tool with a simple hypothetical example. The Cost Opinion tool is a supplement to the Benefit Cost Analysis BCA toolkit. This tool can help users develop a sketch-level cost opinion for their project. The tool includes costs for 16 common active transportation project elements. They are each proven safety countermeasures that have supporting crash modification factors, some of which are included in the BCA tool covered in the prior module. The 16 project elements are sidewalks, crosswalk visibility enhancements, rectangular rapid flashing beacons or RRFBs, pedestrian hybrid beacons, PHBs, also known as HAWKs, median refuge island, conventional bike lanes, buffered bike lanes, separated bike lanes with flex posts, separated bike lanes with concrete median, road diet, shared use path, curb extensions, traffic circles, speed humps, speed cushions, and pedestrian bridges. The Cost Opinion tool is intended to help you develop preliminary project costs when a detailed opinion of probable cost is unavailable. You can also use the tool to develop detailed enough cost information to include in many grant applications. If there has already been some preliminary or detailed engineering of your project, you likely do not need to use this Cost Opinion tool. The opinions of cost included in this tool were developed by compiling costs from ODOT construction project bid tabulation data from previous projects. This data from constructed projects was then used to develop average line item costs for typical items included in the construction of each active transportation element. Then, standard designs for each element were developed with specific assumptions made about the design. For example, in the Sidewalks tab of the tool, shown here on the right, there are 9 typical pay items identified, such as excavation, 4-inch concrete walk, and curb ramps. Each element lists a typical unit price based on actual costs paid on ODOT projects. Each pay item also includes a typical quantity per 1,000 linear feet of sidewalk based on assumptions for project details, such as sidewalk width, number of driveways, and number of curb ramps. Ultimately, each project element tab includes a total cost per 1,000 linear feet of that element or for each element. These costs are also reported on the Summary tab in one simple table for reference. Project costs are reported in 2 versions. First, as part of a larger project, and second, as a standalone project. The part of a larger project cost is slightly less expensive because of potential cost savings on mobilization and maintenance of traffic when bundling these elements with a larger roadway construction project. These cost opinions do not account for unique conditions, including but not limited to railroad coordination, right-of-way acquisition, need for retaining walls or other structures, and private utility relocation. You can manually adjust your project costs if you have additional information about these or other unique costs. This Cost Opinion tool is not able to provide preliminary costs for these items. Each of the 16 typical Cost Opinion tabs within the spreadsheet includes a list of assumptions, which vary based on the project element. In the example on this slide for the shared use path cost, the assumptions include path width, number of driveways, width of driveways, number of curb ramps, the area of each curb ramp, and the assumed length of cross-street interruptions per mile. Even though these assumptions are per mile, the cost opinion is per 1,000 linear feet. In addition to assumptions about the project's design, there are also assumptions for contingencies and inflation. These are listed as percentages multiplied by the total construction cost. In the shared use path example, the construction contingencies include an additional 5% for mobilization, 5% for maintenance of traffic, MOT, 5% for erosion and sediment control, and a 30% contingency for project unknowns that may come up when the project goes into more detailed design and construction. The tool also allows for project cost inflation adjustments. By default, no inflation is added to the project costs, which are in 2024 dollars. You can adjust by considering when the project will be constructed, also known as the build year, and assuming an annual inflation rate between 2024 and the build year. Lastly, there are two engineering contingencies, 15% for design engineering and 10% for construction engineering. You can make refinements based on your local project context. Let's use a shared use path, for example. Imagine our shared use path has the following characteristics: 11-foot wide path and 30 driveways per mile. First, note that the default values for these two variables are 12 feet for the path width and 20 driveways per mile. Also, note that the path is assumed to not disturb existing driveways. This means that increasing the number of driveways will decrease the amount of path we need to construct. You can change any of the assumption values by replacing the default value. Changing the assumption values will change the quantities for the relevant line item. So, for our example project, we will change the path width to 11 feet and the number of driveways per mile to 30. Once these values are changed, the calculations that rely on these values will automatically update. Let's compare the typical default cost on the left and the customized project cost on the right. The differences are highlighted here in red. In our example case, the assumptions reduced all of the quantity values. This in turn changes the overall cost for each line item per 1,000 feet of shared use path. Looking at the overall summary cost per 1,000 feet of shared use path, you can see that the cost per 1,000 feet in our example project has gone down from $162,000 to $148,000 because our example uses a narrower width with more driveway crossings from the default. Both changes decrease the cost since a narrower path requires less materials, and as noted previously, the path is assumed to not disturb existing driveways. Now, let's take this one step further and dive into an example use case of the cost opinion tool for a project with multiple active transportation elements. Our hypothetical project includes one 4-mile long, 10-foot wide shared use path, and one rectangular rapid flashing beacon RRFB installation, which includes 2 assemblies. To start with the shared use path cost, the first step is to navigate to the Shared Use Path tab on the spreadsheet on the bottom right of the screen. The second step is to change our assumptions. In this case, we want to change the width of the shared use path from the default of 12 feet to 10 feet wide for our hypothetical project. The third step is to navigate to the Summary tab of the spreadsheet on the bottom left of the screen. Each Active Transportation Element tab is linked directly to the Summary tab. The Summary tab reports 2 cost options, as part of a larger project or as a standalone cost. As noted earlier in the training, the part of a larger project cost is slightly less expensive because of potential cost savings on mobilization and maintenance of traffic when bundling these elements with a larger roadway construction project. We are assuming we will build this hypothetical project as a standalone project, so we will pull the standalone project cost per 1,000 linear feet of shared use path in cell E11, which is $174,000. Now that we have our cost per 1,000 linear feet of shared use path, the next step is multiplying this number by the project length. In our case, the project is 4 miles long, or 21,120 feet. To get our cost for 4 miles of shared use path, we will multiply the cost opinion of $174,000 per 1,000 linear feet by our overall project length in feet divided by 1,000, which is 21.12. This can be understood as having about 21 1,000-foot trail segments that each cost $174,000. This gives us an overall cost of $3,674,880 for our 4 miles of shared use path. The next element in our project is the installation of rectangular rapid flashing beacons, aka RRFBs, at one location. This one is a little simpler because we do not need to change any design assumptions. Therefore, in this case, we'll look at the Summary tab and use the standalone cost of $38,000 for each installation of RRFBs, which is one total in this project. It's important to note that the RRFB cost opinion includes 2 RRFB assemblies, one for each side of the road, as shown in the detailed RRFBs tab. Using the cost opinion tool, our total project cost is $3,674,880 for a 4-mile long, 10-foot wide shared use path, plus $38,000 for installation of 2 RRFB assemblies at one location, for a total project cost of $3,712,880. This wraps up Module 3, our overview of the Cost Opinion Spreadsheet Addendum to the Benefit Cost Analysis tool. In Module 4, we'll provide an overview of estimating future trips for your project. Thanks for watching. When you're ready, you can continue to Module 4 Trip Estimation. For more information and resources, please visit the ODOT Active Transportation page at the link shown here.